Hello everyone, it's Mr. Wolf here, and in this video I'm going to be going over proportional reasoning with number 1 right here. Your worksheet might look a little different because, if you guys notice, I have very little room to write out everything, so I'm going to try to edit your worksheet for this, but since I'm already starting this video, let's just go ahead. But again, yours might look a little bit different, so I could give you some extra space here. So cargo plane A and cargo plane B are taking off from the airport. Assume both are the same type of airplane, so they have the same thrusting force and negligible friction force. And both accelerate over the same distance of a runway. So really quickly, I'm kind of realizing I'm working with proportional reasoning, so I think it's going to be really, really helpful to make that chart where we have actual values, actual numbers, and then factors. Remember, actual numbers have like units behind them. Factors are things like, oh, it's the same, or it's twice as much, or half as much. Right? And so they have the same type of airplane. So what does that mean? They have the same thrusting force. So I'm going to say, okay, force is going to be the same, so force equals 1. Negligible friction force, so what I could actually say, negligible just means like no friction force. So I'm going to say push force, in this case, is going to be 1, is going to be the same, but my force of friction is going to be 0 because there's just nothing, right? Even though it is the same, it is 0, so I'm going to keep it at 0. Both accelerate over the same distance of the runway, so my distance is going to be the same. But it says cargo plane A is going twice the speed of cargo plane B. So I'm going to say my velocity is going to be 2 for twice as much. Now I think it's important to say these are factors for plane A, let's say, right, where the velocity for plane A is twice as much. So it says cargo plane B has a mass of 20 kilograms. I know that I've been putting in everything into this factor column, but notice that there's a unit behind it. This is an actual number, so I have to say, okay, the mass, the actual mass of this, of cargo plane B, so I'm actually going to highlight that here, of cargo plane B is 20,000 kilograms. Okay. So then, let's see, what am I even solving for here? Oh, question answer. By what factor is cargo A's plane mass different from cargo plane B's mass? All right, so if I'm talking about cargo plane A, okay, these are all the factors for A, so that's what I'm looking for. By what factor does the mass change? So it looks like they're the same type of plane, so the same force and everything, but cargo plane A must have different amounts of things that they are shipping, right, if they're cargo planes in this case. Right? And I know the mass of cargo plane B, but again, I'm trying to figure out by what factor the mass of cargo plane A changes by. So just like with LT5a problems, I'm going to start making my LOLs. Right? And even though that these are different types of planes, the scenario is the exact same. So I could draw this for A or B. It doesn't matter. It's the same situation. So I'm going to always ask for, is there velocity for kinetic energy? Is there height for potential energy? And they're on a runway, so no height. But it says waiting on runway before the engines are on. So, oh, they're not even moving yet either. So just no kinetic or potential energy here. And then afterwards, it's at the end of the runway. So like just before they lift off the ground, it looks like. So if that's the case, then, and again, it says upon takeoff. So they haven't lifted off yet, so which means that my height is 0, so no UG, but definitely going to be moving, right, in terms of being at the end of the runway. So there is velocity, so I'm going to draw some K. Again, I could choose to draw 2 blocks. I could decide to draw 4 blocks. I'm going to draw 3 in this case. Right? So in order for this to work out, we know that energy had to go into our system. If I started with no energy in my system and I end with energy in my system and kinetic energy. So we know energy is going in, but then we also have to think about, well, what caused that? Let's match it up with that. And in this case, remember, work, or not in this case, in all situations, what causes work or energy to go into our system is an outside force. Is there an outside force? Well, there's no friction, it says, right? But it looks like that they have some thrusting force or like a push force essentially. So it looks like, yeah, like we have a cause to have energy go in here. 3 energy blocks. So work caused by, right? You could say FT or F thrust, all right? I'm going to say force push, but you could say F thrust. I'm fine with that. Either one works, all right? So now we have conservation of energy. Does our total amount before equal to total amount afterwards? Yes, there's 3 and 3. The only difference is the energy's wasn't in our system. Now it's gone in, and now we're here at the end. So now I'm going to draw my equation. There's no energy at the beginning, so 0. I have work at the beginning. I don't really need a plus, or I guess this would be plus because work's going into my system. So it's just positive work. And then that's going to be equal to K, which kind of makes sense, right? The work that's going in is equal to the kinetic energy afterwards as well. So then when I write this out in variables, it's going to be FD, my equation for work, is equal to 1/2 mv squared, my equation for kinetic energy. Now I'm going to use this equation to solve for, again, what am I looking for? It's by what factor does cargo plane A's mass change, or is it different than cargo plane B? If I am looking for a factor, then that means that I could only use factors to solve this. This 20,000 kilograms right here, that's an actual number. This is not going to help me if I'm solving for a factor. I have to use factors. So for force, let's see, I'm going to plug in, again, my force of friction 0, but this is the energy caused by the force push, so that says that it's the same type of airplane that has the same thrusting force. Okay, so if that's the case, then I'm going to plug in a 1 for F. I'm going to draw the F up here too. All right. The distance, again, if I go to my factors, is the same, so I'm going to plug in a 1 there. Is equal to 1/2 mv squared. But remember, if I'm proportional reasoning, I don't care about the 1/2 because that variable will never change. I only care about variables that could change. And so no 1/2. My mass, well, that's what we're trying to figure out. By what factor does cargo plane A's mass change? So I'm going to plug in mass here. My velocity is twice as much for cargo plane A. So then I'm going to put in a 2 here, and that's squared. So now 2 squared is 4. All right, so now to kind of simplify everything, 1 equals m4. All right, so what I'm going to do is I'm going to divide 4 by both sides. So if that's the case, my mass is 1/4 as much. All right, so by what factor is plane A's mass different? 1/4 as much, I could say, for plane A. All right, so now I got my factor. What is the mass of plane A? Well, I know the actual mass of plane B, right? That is the 20,000 kilograms. So maybe I say, okay, plane B is 20,000 kilograms. All right, and to find the mass of plane A, well, I know that the mass of plane A is 1/4 as much. So I'm going to multiply it by that factor. 1/4. So then that gives me the mass of plane A, which would be 20,000 times 1/4, 5,000 kilograms in this case. And this would be an actual number, the actual amount. All right, thanks for watching, everyone.